Internet Protocol Security, or IPsec. If we start with its history, we can see that the Internet was not designed with security in mind. At that time, it was a private, controlled environment. It wasn't the giant public internetwork of things that it is today. TCP/IP wasn't designed with embedded security as a foremost concern, because at that time it wasn't envisioned as to what it would become. Security, when it was implemented at higher layers, like SSL or Secure Socket Layer for HTTP and FTP, and Secure Shell for remote command line interface connections. But what about other applications that needed to be secured or need security? IPsec was designed to solve this problem, to implement security for IPv4 and IPv6 at the internet layer, therefore securing all of the applications and protocols in the upper layers above it. IPsec provides us with some basic things that are needed in security. One, authentication for data origin, being able to authenticate that your data came from where you think it came from, integrity, that it wasn't changed en route, and protection against replay attacks if the information or the data was intercepted, like in a man-in-the-middle attack. AH, or authentication header, can provide those things through IPsec. IPsec also provides encryption for data confidentiality, for keeping our data private, as well as authentication with integrity checks and protection against replay attacks. ESP, or encapsulating security payload, can provide us with those things. That's also part of IPsec. IPsec also provides us with negotiation of security associations and keys through ISACAMP, IKE, and Diffie-Hellman, or DH. IPsec has two modes: transport mode or tunnel mode. Tunnel mode is what's used in VPN tunnels. IPsec can be implemented in the kernel of the operating system, or it could be added to the stack. This is more typical. You have the application layer, which is in software, the transport layer, where we have TCP and UDP, that's in software, and the internet layer, or IP layer, which also exists in software. IPsec is added at the internet or IP layer and is implemented in software. In comparison to the network access layer, where we have the data link layer and the physical layer, which is implemented in hardware. When we use IPsec and have it added to the stack in an end device, it's called a bump in the stack. When IPsec is added to a network device, like a router, it's called a bump in the wire. In this slide, you have all of the protocols used in IPsec. IPsec is more of a suite or framework of protocols and security technologies than anything else. Let's take a look at the main protocols. The main protocols are AH, ESP, SA, and IKE. Now, AH, or authentication header, is more of a header than a standalone protocol, and it's waning in popularity because although it can provide the ability to authenticate data origin, that the data is from where you think it's from, as well as the integrity of the data, that it wasn't changed en route, it doesn't provide confidentiality or encryption. Authentication header also doesn't work with NAT firewalls. It can't traverse network address translation. Encapsulating security payload, or ESP, does provide confidentiality through encryption, and it can provide some of the same authentication methods like integrity checks to be able to verify the integrity of the data. ESP is more popular because of those reasons. Now, security associations are used to set up basically a contract or a recipe for how security is going to be handled from each device or from each end of the IPsec connection or tunnel. Now, security associations are built on IKE, or the Internet Key Exchange, and IKE uses the policies laid out in ISACAMP to set up these security associations. Now, there are two phases in IPsec. There's the Phase 1 Security Association and the Phase 2 Security Association. Phase 1 is used for management and Phase 2 is used for data. Phase 1 creates the policy set and Phase 2 creates the transform set. There's a single policy set used for management in Phase 1, and there are two, one inbound and one outbound, transform sets used for data. Now, all of the things that are set up in these two phases in these security associations are basically all of the security methods we're going to be using. So in Phase 1, what's negotiated is the policy set, and there we lay out the encryption that's going to be used. Let's say it's 3DES or AES. The hashing that's going to be used, either MD5 or SHA with HMAC, which is a keyed hash. The method of authenticating each end of the IPsec tunnel using X509 certificates with either pre-shared keys or public key, and the Diffie-Hellman group that's going to be used to share those keys across the internet. Phase 2 negotiates the transform set. Now this is used to secure the data. Now the transform set, we set up the encryption that's going to be used. Let's say we're going to be using ESP with AES encryption and a 256-bit key. And the hashing that'll be used for the integrity check, let's say we're using ESP with a SHA hash with a keyed hash using HMAC. Those are the basic protocols or the suite of protocols that you'll see in IPsec.